Let me give 1 second. Cauchy distribution we completed. In the applications of rectangular distribution or uniform distribution, we covered it to we completed two examples, 7.1 and 7.1.2. So now we need to complete 3, 4, 5, and then again we'll go for the next applications of the normal distribution 1. So now we will do the third example. So what is the third example? If X follows uniform distribution or rectangular distribution with the parameters minus b comma b, find the value of b. The value of b we need to find that, and such that what they are saying is p of x less than 1. If you are taking x less than 1, like its value is less than 1, then it is equals to p of 3 into p of x greater than 1. So this they gave it. No. In the solution part, first we'll write x follows the uniform distribution with the parameters minus b comma b. Then the probability mass function. For the uniform distribution, the mass function, right? In the normal other Cauchy, gamma, beta, we'll have probability density function. So for the uniform distribution, we'll have probability mass function. We will call it as PMF. PMF of x is, so what is the uniform distribution? F of x is equals to 1 by 2b, right? So f of x is equals to 1 by 2b. So now the condition they gave is p of probability of x less than 1 is equals to 3 times of probability of x greater than 1. So we will take that thing and we will do the integration part. So this can be written as uh, like in the two cases we'll write minus b to the 1 as one integration and 1 to the b, two integrations part will write. So from this, what is f of x? Will substitute the f of x value 1 by 2b into dx. Here also will substitute x. So what happens? This 1 by 2b comes outside and it will be integration of minus b into 1 x into dx, x into dx. So x into dx means in the place of x will substitute 1 into dx, sorry, 1 into dx. So 1 integration if we do, then it becomes x. X means 1 to dx is equals to x. Then what is the integration part? 1 minus b. So in the place of x, first we'll substitute 1 and again we'll substitute minus b. So like this also for the same thing. And then what happens? B minus of minus b is plus b, 1 plus b, and 3 into b minus 1 is equals to 3b minus 3. So after calculations, 1 plus b is equals to 3b minus b, 3. So b one side and numbers other side. So if this b come this side, it will become 3b minus b and 1. And if this plus 3 minus 3 comes this side, it becomes plus 3. So this is 4 equals to 2b. And 2 ones are 2 twos are. So what is b value? B is equals to 2. B is equals to 2. So like this, you need to find out. Next, coming to the other example, show that for the rectangular distribution, P of f of x is equals to f of x is equals to 1 by 2a, with the x having the interval of minus a to a minus a to a, and the moment generating function origin is 1 by 80 sine h 80. Also, now the movement of even order to the given things for the even orders like even means 2, 4, so on any order like even order, it is given as mu 2n is equals to a power 2n by 2n plus 1. So this is they given. So we need to show what. So we need to moment generating function. What is the formula? So it is m of mx of t. Mx of t means we can write it as expectation of e power tx. So expectation of something can be written as a integration part into that part into f of x, right? So saying integration minus a to a e power tx into f of x into dx. So what is f of x? F of x is 1 by 2a. We will substitute f of x value as 1 by 2a. Again, the 1 by 2a comes outside. For this integration, if we do t power ex, it becomes t power ex by t. T power tx by t integration if we do. So after that, so in the x value, one time we need to substitute a value as well as other time we need to substitute minus a value. So t of e of tx by t, right? So I'll substitute a value once and this value again. At by t. Again, by, right? Then it comes like this. E power minus of minus t, I'll take by t, and this t comes outside. In this we can see 1 by 280 is a common. So after writing this, this is the formula of what? This is the formula of sine. In the previous one we have so, right? So this is the formula of sine HAT, sine HA. Actually sine HA, but in the place of A we have the sine AA, like 80, right? So the formula becomes sine HAT. So 1 by 80 into sine HAT. So it can be written how sin HAT can be written. It can be written as continuous, like AT plus AT cube by 3 factorial plus AT power 5 by 5 factorial and so on. So this is the required one. So since, yeah, since there are no terms with the odd powers of a t in the mx of t, all movements of the odd order about origin vanish. That is mu 2n plus 1 dash about origin equals to 0. In particular, mu 1 dash about origin equals to mean is equals to what they are saying, mu 1 dash and mean equals to 0 they are saying. So mu 1 dash equals to mu r. So what happens when in the mu 2n plus 1 dash is, we are taking what the values of n, right? So n values are 0 to infinity. So all moments of the odd numbers about mean vanish. So all the moments of the odd order, whatever you are taking, it will vanish. So the moments of every even number is given as mu 2n is equals to coefficient. We need to take the coefficient of t power 2n, t power 2n by 2 factorial, 2n factorial anything. In what? In this mx of t. In mx of t, we need to take the coefficient of this. What is the next question? The next question is example 5. So on average 30 minutes, TV shows have 22 minutes of actual program. Let's assume that the probability distribution of the number of minutes of the actual program is uniformly distributed from a low of 18 minutes to high of 26 minutes. We are assuming it maybe 18 minutes to low, we are taking as 18 minutes, as well as high, we are taking as 26 minutes. What is the probability that the show will have at least 25 minutes of probability? So actually we have 30 minutes of program. So in that 30 minutes of program, so what is the probability that 25 minutes of the program is running? Only actual program is running. So what is the probability we need to find? And what is the probability that the show will have been between 21 to 25 minutes of the programming? So what 21 to like 21 and 25, what it will be? You need to tell the probability also. We'll solve it. Yeah. So let's solve it. So what? Let x be the random variable. We are taking x as a random variable and denotes the number of the minutes. So x here, x we are using to denote the number of the minutes of the actual program. So which follows a uniform distribution with PDF, with the PDF What is a PDF? We are taking f of x is equals to 1 by b minus a. So what is the integration part? Lowest we are taking 18 and highest we are taking 26. So if we substitute these values b minus a, it will become 26 as a b and 18 as a. It will become 1 by 8. Normal f of x is 1 by 8. Now what is the first question we are having? The first question we are having is probability that the show will have at least 25 minutes of program they are asking. So 25 minutes of the program means, so maximum is 26 it can be. And they are asking 25, minimum 25, at least 25. So in the lower amount, like lower limit, we need to take 25 and the upper limit, we need to take 26. So same like this only. It will be integration of 25 into 26 f of x into dx. So f of x already we did. So what is f of x value? 1 by 8. So we will substitute that f of x. When we uh, keep this 1 by 8 outside, it will be 1 into dx. Then 1 into dx, if we do differentiation, it will become x. So in this place, we need to substitute 26 and 25 once. So 26 minus 25 is, we know, that is 1. So 1 by 8 is 0 0.125. This is what? This is the probability that the show has at least 25 minutes. At least 25 minutes. So what is the second question? So probability that the show will have between 20 and 21 and 25 minutes of the programming. So what happens? What is the probability? 21 to 25 minutes if it is having a, in between that. So what we need to take? So we need to take this as a lower limit and this as the upper limit, right? So same thing by the previous one. In the place of 26 and 25, we'll substitute 25 and 21. F of x will substitute 1 by 8. So again, 1 by 8 comes outside, then it becomes integration of 21 to 25. X 1 into dx. 1 can be written as, in the differentiation we do, if we do 1 into dx differentiation, it will becomes x. X. Okay, x. So x. So x into what is upper limit and lower limit? It is 25 and 21. We'll substitute 25 and 21. So it becomes 4. So 4 ones are 4 twos are 1 by 2. 1 by 2 is half, means 0 0.8. 0 0.5. Sorry, 0 0.5. So I think you understood. So like this, you need to find out. So first question first we need to find out f of x. So after f of x, like you can, it will be easy for you if you find out f of x in the like before only. So after finding f of x, we need to find out the second question is at least 25 minutes means we need to take lower limit as 25 and upper limit as 26, because in the question only they mentioned the lowest is 21 and then upper, like highest is 26. So for second one, if we are having the program between 21 and 25, this is the probability that 0.5% there is a chance, half chances like a. Next. Okay. This application part is completed. Next. Now we are into the applications of normal distribution one. So we completed the applications of what? We completed the applications of the normal distribution. Sorry, and we completed the applications of uniform distribution, or else we can say it as a rectangular distribution also. So now let's see what are the applications and how we will implement that normal distribution in the examples problems we'll see now. So coming to that, in this unit or in the unit 8, we will cover the four things here. So after studying this unit, you will, means we will able to do these things. Learn how to transform a normal random variable into a standard normal variable. First, if they give any normal random variable, we will convert it into the standard normal variable. Second, we will find the area under the standard normal distribution. So under the standard normal distribution, we will find the area of the particular region. So next, we will find the probabilities for the normally distributed variables. So for the normally distributed variables, what we'll do, we will find out the probabilities. After that, so finding the specific data values for the given percentage using standard normal distribution. Using the standard normal distribution, what we'll do, we will find the specific data values actually. From the given percentage, what are the percentages that they gave? From that, we will find out the specific data values actually. By using what? By using standard normal variance. So coming to the method to find the probability when the variate is normally distributed. So when the variate is normally distribution, so how to find the probabilities, we'll see in this method. Let x be a x be a normal variate with a mean mu. Mean is what? Mean is mu. And standard deviation is sigma. So we are taking x as a normal variate, and for that variate we are taking mean as a mu and standard deviation sigma. Suppose we want to find the probability that a randomly selected value x will between a and b is, so if we are assuming anything like what is the value of the x, then it lies we are assuming that it lies between a and b. So this can give probability of a less than x less than b, means the x value is between the a and b. So we will assume probability of the x is having the limits between, means the value of x is between a and b. A and b means, so it is having like a to b between. So first step, what we need to do means we need to convert the x into a normal standard variate. So we need to convert, what we need to convert? We need to convert the x value into normal standard variable. So variate. So how we will convert? By the formula z is equals to x minus mu by sigma. X is equals to mu by sigma. So find the limit of the z corresponding to the limits of z x. So what we need to find? We need to find the limits of the z corresponding to the limits of x. Limits of x. So x is equals to a. X is equals to a. So x is equals to a. Then z will what happens? In the place of x, will substitute a. So a minus mu by sigma. So if you are taking x is equals to b, this becomes z is equals to b minus mu by a sigma. So the limits are z. The limits of z are a minus mu by sigma to b minus mu by sigma. These are the limits we need to find out. So what is the third step we need? How the third step is what in the previous only we learned, right? The probability of x is having the limit value between a and b. So the a is changed into this a is changed to a minus mu by sigma, and b is changed to b minus mu by sigma. So these are changed. So next, what is the fourth step? Fourth step is from the table, find the probabilities that are lies between. So these values we need to find out from the table actually. So these are the steps to find out the things. So next problem is, so quartile deviation problems on the normal distribution. Deviation we'll see on this problem, normal distribution. Example, what they get? So prove that the normal distribution, the quartile deviation, the mean deviation, and the standard deviations are approximately what? Approximately to 10 is to 12 is to 15. What they are saying? The normal distribution is 10 and the quartile is, sorry, the normal distribution of the quartile distribution, mean deviation, quartile deviation, and standard deviations are in the ratios of 10 is to 12 is to 15. We need to prove that. Okay, we'll do. First, So we are assuming BA XB, like any random variant. So it is following the normal. It is following the normal distribution with the parameters what? With the parameters what? With the parameters. So XBA any variant. So it is following the normal distribution with parameters mu and sigma square. Mu and sigma square. We can assume it as mean and variance. Like that. Mean and the standard deviation also we can take from that actually. Okay. So if Q1 and Q2 are the first and Q1, okay, you need to take this as Q3, not Q2. So Q1 and Q3 are the first and third quartile respectively by the definition. So by the definition, how we can write? So P of probability of X is less than quartile 1, means we are taking it as 0.25 chance. So, and the probability of X greater than quartile 3 is 0.25 only. Then we'll substitute that values in the this thing graph. So it will be, so the points Q1 and Q3 are located as shown in the figure below. So this is quartile 1 and this is quartile 2. This is the X is equals to mu. So this is also 0.5, 0.5, and this shaded part is also 0.5, and this shaded part is equals to 0.5. So the X is equals to Q3. X is equals to Q3. Then what happens? Z is equals to Q3 by Q3 minus mu by sigma. See, in the place of V, we are substituting just Q3. That's it. So we say for the Q1, we'll substitute in the place of Q3, we'll substitute Q1. That's it. From the above figure only we can. So by subtracting both Q3 and Q1, so we'll get this and this can be cancelled, and mu 3 Q3 minus means quartile 3 minus quartile 1 by sigma is equals to 2 Z1, because Z1 minus Z1, this comes this side, right? So Z1 plus Z1, it becomes 2Z1. The quartile deviation is given by quartile deviation. So the quartile deviation is what? Now Q3 minus Q1 by 2 is equals to sigma. This sigma I'm sending this side. So sigma Z1. Sigma Z1. So for the from the figure, we can say that P, we can take a lower limit as 0 for Z and upper limit as Z1. Then this is equals to 0.25. So Z is equals to approximately, we can say 0.67 from the normal distribution tables. We can take it from the normal distribution table. So quartile is what? 0.67 sigma. 0.67 sigma. Yeah. Okay. So now coming to what happens, 0.67 can be written as 2 by 3 sigma. So from the normal distribution, mean deviation is what? So mean deviation will have root 2 by pi sigma. So 2 by pi sigma we can write as 22 by 7. Again, it this goes. Like we can simplify it actually. 22 by 7 means 22 by 7. This comes 7 by 22. Ones are 11s are again. We need to calculate that. And it is approximately 4 by 5 sigma. So one thing is 2 by 3. Other thing is 4 by 5 sigma. And the standard deviation is sigma, because what we took as variance there. So variance as sigma square, right? So root of variance is equals to root of variance is equals to standard deviation. So root of sigma square is equals to sigma. Root square cancel sigma. So sigma is a zero. So what happens? Sigma 4 by 5 sigma, 2 by 3 sigma. Sigma, sigma can be cancelled, 2 by 3, 4 by 5, 1. So when we take the LCM, what becomes the LCM? So now let's assume we'll take the LCM. So LCM will be 15. So 3 5 times, 2 into 5 is 10, plus 4 3 times, 3 4s are 12, and 1 15 times, 1 into 15 15. So what this becomes, so 10 is to 12 is to 15, 10 is to 12 is to 15. So the ratios are correct only. So this is the example actually to find the ratios. Next, coming to other example. What is the example? So the marks of the students in a class of 100 are normally distributed with a mean mark as 40 and variance marks 400. Find the Q3, quartile 3 as well as the quartile 1. And second thing, same quartile 3 and quartile 1 we need to find out. Then again, we need to find the meanness, like coefficient of the quartile deviation, coefficient of the quartile deviation also. So we'll do it. So coming to the solution part, now since normal curve is symmetrical about mean, the first quartile and the third quartile are equidistant from mean. So it is equidistant. We can assume it is a equidistance because it is a symmetrical. It divides into equal parts. So given, so mu, what they are given? X bar. X bar means nothing but mean, right? Mean is equals to 40 and variance is equals to 400. So what is the standard deviation? Standard deviation is a square root of variance. So square root of variance is standard deviation. So sigma is equals to root 400. So root 400 is equals to 20. 20, 20 is a 400. So Z corresponding the area of 0.25. 0.25 it is equal. So the mean is from the mean of from the mean of that one table 0.675. So how to find the standard normal variant? We have a formula of Z is equals to X minus X bar by sigma. So in this values, we need to substitute the values. So what is the Z value? Z value is 0.0675 is equals to X. X bar is 40 and sigma is 20. So this comes this side, it will become 13.5. So again 13.5, this minus 40 comes this side, it becomes plus 40. So 40 plus 13.5 is 53.5. That is Q1. What is the Q2 value? Then Q2 is equals to that 40 minus, the remaining part is this only, right? So we need to minus it from this. So 40 minus, this is 40 plus, and this is minus. Sorry, this is plus and this is minus. This is plus and this is minus. So plus is this and minus, if we do 40 minus 13.5, then it is 26.5. So that are the Q3 and Q1 values. So what the other thing they gave? Other thing from the previous one, we can say Q1 is equals to 26.5 and Q3 is equals to 53.5. So they already asked the coefficients of the quartile deviation. Coefficients of quartile deviation can be represented as Q3 minus Q1 by Q3 plus Q1. So we'll substitute the values and we'll get 0.3375. We'll get the 0.3375. Next, coming to the standard normal variate problems. If Z is given, so if we know the Z value, then how to find out? We'll see. So what is the topic? A standard normal variate problem. If Z is given, if the Z value is given, how to find out? So if example one, so if Z is the standard normal variate, find the probability. We need to find the probability. To the left, so left is what? minus 1.78. And to the right is, they are saying right is minus 1.45. And the corresponding to 0.80 means approximately, and z approximately 1.53. To the left, they are taking minus 2.52, and to the right they are taking minus plus z is equals to 1.83. So these are the things they given. So how we need to solve, we'll see. So okay, coming to this. So to the left, what they said, to the left it is 1.78. So we'll take 1.7 as the upper, and we'll take minus infinity first. So what happens, pi of z into dz. So in the pi of dz, again in the minus 1.8 can be written as uh, minus infinity to integration minus infinity to minus 1.78 can be written as, how it can be written as, so minus infinity to 0, and another is minus 1.8 to 0. So like this they can be written split. So we are splitting like this only, this one. So in the place of this, we are substituting 0.5, 0.5, and this place we need to solve it. So if you substitute these values here, you'll get approximately values as 0.4625. So when you minus this, you'll get 0.0375. 0.0375. To the right. So left is completed. To the right, we'll do now. To the right, what happens? So to the right, z is equals to minus 1.45. So we'll take probability z greater than minus 1.45. So again, minus 1.45 can be written downward lower boundary. So again, it can be split into two integrals. So by the symmetry as well as pi of into dz, it is symmetry. We can write it as half. It is cutting, right? So this is 0.5, and the value of this is 0.4265. You need to substitute that values and you need to calculate. Next, corresponding to 0.80, this is 8.080, and 1.5, 1.75. So this area we need to calculate. So again, what we'll take, we will take minus 0.80 as the lower boundary, and 1.53 as the upper boundary. So we will split the integral part into things, two integrals, then we'll substitute. So two are different values, right? By calculating this value in the calc, you'll get 0.3159, and by substituting these values, you'll get 0.4370. If you are adding both, you'll get 0.7529. 0.7529. Next, coming to the fourth one. So what is the question in the fourth one? To the left, to the left, z is equals to 2.52, and then to the right, it is z is equals to 1.83. So again, integral part is again, in the upper boundary, we'll take minus 2.52, and in the lower boundary, 1.83. So minus infinity to the infinity, two different integrals will like that, we'll split like that. Again, what happens, this thing can be split into two. Again, this is split into two. So how they are splitting? So minus infinity to the minus 2.5 can 52 can be represented as minus infinity to 0, and minus 2.5 to 0. Again, 1.83 to the infinity can be represented as 0 to the infinity, and 0 to the minus 1.83. So they are changing, the upper boundaries are changing actually, upper and lower boundaries are changing. So this becomes, we know, 0.5, and this becomes 0.5. We'll substitute these two values, 1.83 and 2.52 from the call sheet. So we'll calculate, we'll get 0.388, 0.0388. So this problem is also completed. So next, coming to the application problems on normal distribution, we'll see the normal distribution problems. It will be easy, only same like that only. We have three problems, again four, five problems. So if we complete five problems, then it's completed. Yeah, five problems we will complete now as much as possible. Coming to the application problems on the normal distribution. So the first example is given as the length of the life of an instrument produced by a machine has a normal distribution with a mean of 12 months. Mean is what? 12 months. And the standard deviation is 2 months. So find the probability that an instrument produced by a machine will be last. So you need to find out the probability that it will last less than 7 months. So actually mean is 12, but what happens? What is the probability if it lies less than 7 months? So and second one is 7 to 12 months it is working, like between any time 7 to 12 months it is working, or any not functioning proper. So what is the probability that the chances that it will have? So solution: if X denotes the length of the life of an instrument produced by a machine, Z X follows normal distribution mu comma sigma, and it is standard deviate variant. We know the formula. It is as Z is equals to X minus mu by sigma. Z is equals to X by mu minus sigma. X is equals to mu by sigma. So what happens for the mean? We are taking what the values of mean as a first thing, 12 months. So 12 months means mu value will need to substitute as 12. So in the place of mu, we'll substitute 12. So X minus 12 by 2. So probability that an instrument produced by this machine will last that 7 months, less than 7 months. So what they are asking the first question, less than 7 months, then what is the probability? So we will take probability of X less than 7. So X less than 7, it means Z less than 7 minus 12 by 12. In this place X plus, we'll substitute X value. So what it becomes, Z, if we calculate 7 minus 12 by 2, it will, what it will be? Minus 5 by 2, then it will be minus 2.5 when it is divided by 2. So the value of probability of Z less than minus 2.5, it is 0.0062. You can calculate in the calc. It is very easy to calculate. Next. So what is the second question again? The second question is if it is lasting between 7 and 12 months. So 7 and 12 months, we'll take a lower boundary as 7 and the upper boundary as 12. So what happens? Z1 and Z2 will take, two variables will take. So what happens for the Z? It becomes 7 minus 12 by 5 equals to minus 2.5. This is as Z1. We'll consider it as Z1. And second one, in the place of 7, we'll substitute 12. So we'll see that also. So in the second one, what we are doing? In the second one, we are substituting 12 minus 12 by 5. It is 0. So it lies between what? Minus 2.5 less than Z, minus 2.5 less than Z, and less than 0. So the value of this, if you see in the calc, it is 0.4938. 0.4938. Next, coming to the other example. So what is other examples? I hope you can do this sums. Once I'll explain in a brief, you need to do these sums. So the marks of the 1,000 students in a university are found to be normal distributed with mean 70, and standard deviation 5. And the marks of 1,000 students they are taking of any university. So estimate the number of students whose marks will be. So we need to estimate. We need to find out the estimated value, probability value, that the marks are between the student marks are between 60 and 75. And again, more than 75, how many students are there? What is the probability of having more than 75? Then less than 68, how many people are having less than 68 marks? So first we need to find the standard deviate variation, like standard normal variate, right? So after that, we need to solve these problems. So what is the formula for the standard normal variate? It is z is equals to x minus mu by sigma. Z is equals to x minus mu by sigma is the formula for the standard normal variate. So in this value, we need to mu value is what? Mu is 70 and sigma is 5. We will substitute that. Then if we substitute this, so z is equals to x minus 70 by 5. So what they are saying in the first question, it is between 60 and 75 they are saying. Between 60 and 75. So x is equals to 60 you'll take and x is equals to 75. Both you'll take one time. So if you are substituting x is equals to 60 in this equation, the equation 1, then it becomes 60 minus 70 by 5 minus 10 by 5 minus 2. We'll say it as z1. And if you substitute the second one, what is second one? 75. 75, then it is 75 minus 70 by 5 equals to 5 by 5, then equals to 1. So we will call it as Z2. So now what is the probability? Probability of, we can say, minus 2 less than Z less than 1. So minus 2 less than 2 less than Z less than 1. So this can be written as how 2, you can split it into 2. So minus 2 less than 0 and 0 greater less than Z less than 1. So we need to find the probability estimation value for this, and which is 0.4772, and the probability estimated value of this, which is 0.3414. So after adding the both values, it is 0.8185. 8185. So, so the number of students whose marks between 60 and 70 is, we need to, 1,000 members are there, right? So 1,000 members are students are there. So after coming that value, we need to multiply it into 1,000. So 819 are having the values, are having the marks between 60 and 75. Next. So what is the second question? More than 75. How many people are having more than 75? So more than 75 means what? We will take P z greater than 1. So p z greater than 1, we know pi of x, we can say like that. If we take, it is 0.5 minus this. So this value, as already know, it is 0.3415. So just we are subtracting it. More than 75 people, how many people are there? So if we calculate 0.5 minus 0.3413, it is 0.1587. So after coming that value, so what we need to do, we need to multiply it with the 1,000, then the value is 158.7, which is approximately equals to 159 members. 159 students are having the marks more than 75. So next, what they are saying, less than 68, how many people are there? Less than 68 means less than 0.4, right? So less than 0.5, 0.5 minus 0.4. So the probability of 0 less than z less than 0.4 is 0.1554. So if we subtract 0.5 minus 0.1554, then we'll get 0.33446. So the number of students, what we'll do, we need to multiply it with 1,000. So we'll have 344.6, which is equals to 345 students. So next, coming to the other example. So what is the example now? So entry to a certain university is determined by the national level test. By the national level test. The scores on this test are normally distributed with the mean is 500 and standard deviation is 100. Sai wants to be admitted in the university and she knows that she must score between the at least 70% of the students who took the test. Sai takes the test and scores 585. Will she be admitted in this university? So we need to find that she will be admitted or not with her marks 585. So for the solution, x is a normal random variable, we'll say. So x is following the mean and variance 500 and 100. So for x value, z value, standard normal variate value, we know x minus mu by sigma. So in the x value, what we need to substitute? We need to substitute 558, 585. 585 are the her marks. So minus what is mu value? Mu is 500 and 100. So 0.85. So the potential P of the students who score below 8.5 is given by. So we need to find out the what is the proportions that 855 kanna, like if they are getting the low values. So probability of area of the left of, we'll take left of that value 8585, we'll take the left of the values and we'll calculate. So left of the values, then it will be 0. Z is equals to 0.85, then it can be taken as 0.8023. So see, so like this. So left of the area is what? 0.8023, right? So with 100% we'll do. So if we do with 100, then it will be 80.23. So Sai scored better than 80.23 of the students who took the national level test, and she will be admitted in the university. Like 80.23 is the percentage below the 585. So she scored very good marks, like more than that marks. Then she will be definitely admitted in the university test. Ex- University. Next. So next, coming to the fourth question, the mean height of the soldiers to be 68.22 and inches with a variance of 0.8. How they did not give the standard deviation. So they gave 0.8. So we need to find the root of 0.8, like that. So how many students regiment of the 1,000 would be expected to over 6 feet tall and below 5.5 feet? So first thing is over 6 feet to now only we need to find out, and after that the second question is below 5.5 we need to assume the weight. So we will take mean as 62.22 and variance as 10, variance is equals to 10.8. So we need to like, we know Z is the standard normal variate, Z x minus mu by sigma. So in the place of x, we'll substitute the 72. And so mu value will substitute 68.22 and the variance is root over 10.8. So after calculating this, we'll get 1.15. After calculating that, we'll get 1.15. So the probability that the soldier is above 6 feet is 72 tall is given by, so x is greater than 72. So which is equals to z is greater than 1.15. We need to take greater than 1.15. So 0.5, this will become 0.5, then minus 1.15. So if we calculate the probability of the 0 less than z less than 1.15, it is 0.3449, 3749. So after calculating 0.5 minus 0.3749, it is 0.1251. So you'll have a doubt like from where we are taking this direct values. So from the normal table, we are taking the direct values here. So next is what? So hence the we got the value, right? After getting that value, we need to multiply it into 1,000 because we have the 1,000 soldiers. So it will become 125. 125 members are having the height as over 6 feet tall. So next, what is the question? That the probability of the soldiers is 5.5 feet, means 68, 66 height is given by. So in this place, x place, we need to take 66, and in the place of mu, we'll take 68.22. So this thing set. So after calculating again 0.5 into this value from the normal distribution table, it will be 0.5 minus 0.2501 by, if we calculate this value, we'll get 0.2499. So 5.5, right? So we got this. We need to multiply it into 1,000 to get the number of soldiers we have over 5.5 is 250 people. So next one is fifth question. So what is the question? So in a normal distribution, 7% of the items are under 35 and 89% are under 63. Oh yeah. So find 63. So we need to find out the mean and variance. They already gave the percentage. We need to find the mean and variance. So what it follows the normal distribution with the mu and the sigma square. So mu and sigma square, x is greater than 63 means 89%, it is 0.89, then 0.89. So if it is greater than or equals to 63, it will be 0.11. So and greater than 35, it is 0.07. So after that, we will take x value as 35 and we'll substitute here. We'll say it as z1. So we'll take x is equals to 60 and we'll substitute in the standard normal variant, that is z2. So from these two values, like 0 less than z and less than z2, we'll find out the value. So it will be 0.39. So for that only, after that, similarly, we will do for the z1. So this is z2, right? We find out for the z2 first and we'll find it for the z1 also as a similar process. So So after finding that, so Z1 value we are having as 1.48 and Z2 value is 1.23. So from that we can say 35 minus mu by sigma is equals to minus 1.48 and 63 minus mu by sigma is equals to 1.23. So from these two equations, we can conclude mu is 60.43. If you solve these two equations, then mu is equals to 50.3, and from that you can also find out the sigma as 10.33. These are the values we need to find out. So this is all about the normal distribution applications. So you can practice some exercise sums here. These are the solutions for the exercise sums. So in the next class, we will conclude, like we will start the normal distribution, second part applications of the normal distribution too. So today we completed the remaining part of the uniform distribution, that is rectangular distribution applications, and we started and we completed the normal distribution part 1 applications. So in the next session, we will meet with the applications of normal distribution part 2. Thank you. If you have any doubt, you can ask me in the comment section. Thank you.